So today, like I said, we're going to talk about single and double replacement reactions. And this would probably be fairly new for us, I imagine, yes? I don't know if we've done this before. I don't think so. So we're going to predict the products of single replacement and double replacement reactions. And once again, translate those word equations into actual equations and then balance them, of course. Okay. Single replacement is what we're going to do first. So go ahead and copy this down, guys. Single replacement. Okay. In a single replacement reaction, a reactive element reacts with an ionic compound. So a reactive element reacts with an ionic compound. Okay. In a single replacement reaction, an element, basically, if you want to simplify that, an element reacts with an ionic compound. The element will take the place of another element in the compound. So replacement, single. One replaces the other. Single replacement. Okay? Element reacts with an ionic compound. So you'll see that an element, like calcium, reacts with an ionic compound. And what we're going to do is we're going to switch the element for a different element in that compound. Okay. Just a reminder here, some things, charges of multivalent metals. So if we have metals, we need to be aware that, iron comes in a 2+ and a 3+, okay, things like that. States of metals, of course, and don't forget I have no bright or clever friends, people stupid, yes. States of ionic compound in a solution, it's aqueous, and we're going to use some drop and swap. Okay, so don't forget that as well. Okay, so here we go. I'm going to get you to copy to here. Okay, and let's rewrite this here too. All right, so A okay. So in this case here, if we're talking about a metal, reacts with an ionic compound. Okay, a metal reacts with an ionic compound. So A would be your metal in this case. The BX would be the ionic compound part. And what we do is we switch the metals. Okay, so look, to get our products here, these two are going to switch places. Okay, those two will switch places to get our products. Okay. Now, just so you know, there's a reason this happens. Okay, and that's not, you're not going to find that out until Chem 30. Some metals want to gain electrons more than other metals, basically, is what happens. And if that's the case, then this reaction would take place. Okay, that's what we talk about, more reactive. But we don't need to worry about that. We just assume, in the course, the ones that I give you here, that we're going to switch the metals. Okay, the metal parts. An example. Okay, okay. Don't copy down the next part here, guys. Just follow me here. Let's go down to the bottom here and let's go iron plus, what do we have here? Okay, gold nitrate. I think that's right. Yeah. And we'll put an aqueous here. Okay. So here's an example of single replacement. This is what it looks like. Okay. You'll notice you got an element by itself. Iron is a solid by itself, correct? Look over on the periodic table, guys. It's in gray writing, yes. So you're going to see an iron solid by itself. And then you'll notice we have an ionic compound, right? And we know that this is gold 3 nitrate, yes? Okay. So what happens is, since, look, and this is kind of what determines this, this is a metal, yes? Okay. It's on the left-hand side of the staircase. That's a metal. It will switch positions with the other metal. Okay. So if you look at gold 3 nitrate, what's the metal in gold or nitrate? The metal's obviously gold, yes? So these two here are going to switch positions, okay? And that will be your products, okay? So watch. Gold's going to come out here by itself. So I'm going to write down AU. By the way, do you remember how you can remember gold? AU. Come back here with my gold watch. AU. AU. No. Don't wave at me. That's not cool. Hey? Fine, you know what? No more jokes for you. Hey? Proton walks into a bar? No. Says, hey, why so positive? I told you that one, haven't I? Sure. Okay, listen. Gold comes out by itself. Iron is going to combine with the nitrate. Now, so the iron's going to take its place here. Replacement. Okay, switcheroo. So we get iron and nitrate. Now, guys, we talked about this at one point. It's probably been a while. What iron does that form? What iron charge? Iron comes in more than one charge, right? So you got to remember, it's in the middle part here, guys. Iron comes in more than one charge. It comes in a 3+ and a 2+. Which one does it form? Why? Because it's the first one on the list. Yes? So get your periodic tables out today, guys. Come on. Get your periodic tables out. If you don't have one, let me know. Did I give you one? Okay, good. Yeah. If there's two what? Yes, the non-metal switch places. Yeah. Okay. So if you look on your periodic table, iron 3 comes first. Yes, 3+ comes before 2+. So the most common charge of iron is 3+. So that's what I need to write down here. 3+, nitrate is a 1-. Okay, and I'm going to put an AQ there. Okay. AQ. What does AQ mean again? It's very aqueous and means it's very soluble, right? Right? Very soluble. That comes from here. So you're going to have to use this side too. Okay, this is pretty, there's lots of stuff to remember here today, guys. No, not there. That's the formulas. That doesn't. There. Okay? That's what I'm talking about. So, you know, if you look up nitrate across the top and you find iron 3, it is in the top middle thing there, so it is very soluble aqueous, yes? Okay? Now, we need to balance this as well. One iron, Fe, good. Au. Tony, Au. No. Au. That's good. 3 nitrates, 3 NO3s. 3 NO3s, we're good, yeah? Right? We balanced it. So metals switch places, yes? Okay? So remember that. Good? We put AQ because it's very soluble. If it's not very soluble, we'd put what? Not AQ, we put S, right? Okay. Next. Ooh, geez. Lots of stuff here. Let's get rid of some of this. All right. So look. Come on. There we go. Let's take a look at this example here. Now, actually, I probably should get you to write this out, probably. Yeah, let's do that. Okay. So, a reaction that occurs between a solution of silver nitrate, 1+, 1-. Yes? Swap and drop. Solution. Okay? So, we're going to talk about AQ here. Solution. Okay? If you look up silver nitrate on that solubility thing, nitrate across the top, silver, very soluble, okay? And solid copper, okay? And solid copper. Now there's no charge on copper. That's 0 actually, because copper is not combined. Copper can't lose or gain electrons. It has to be combined with something to lose electrons, and there's nothing just by itself. Okay? So what are we switching here, guys? Tell me. What are we switching? What two parts are we switching? Quickly. Yep. Copper and silver. So we're going to switch the metals. Yes? The old switcheroo. Silver is going to come out by itself. So I'm going to write that down. It doesn't matter which order you do this. And that would be now the solid. Okay? Silver comes out by itself. Silver is a solid. It's a metal. Okay? Copper combines with the nitrate. So copper and nitrate now go together. Now, once again, copper, this doesn't happen all the time, but in this case, copper has more than one charge. Yes? Copper comes in a 2 and a 1. So we need to use the most common one, which is 2. Look on the periodic table. It's the one that comes first, guys. Copper 2 is more common than copper 1. So if this is a 2, I'm going to erase this, so don't write this down. This is a 2 plus, that's a 1 minus. If I swap and drop, right, 2 comes over and down, I need brackets. 1 comes over, I don't need brackets, yes? Okay, so I'm going to get rid of that now, okay? Once again, if you look up nitrate across the top, find nitrate, copper 2 is in the top part here. Copper 2 is not down here, it's right there. So that is aqueous. Okay. Most of the time it's going to look like that. Okay. We need to balance this, yeah. Yeah. We need to balance this. So I got 1 silver, 1 silver. Good. 1 nitrate here, 2 NO3s there. So I need to go back here and put a 2 here. 2 silvers, 2 silvers, a copper, 2 nitrates, 2 nitrates. Good. Okay. Balancing. Alrighty. Good. Questions? Okay. So we switch the metals, right? And we got to keep in mind our most common charges there. Okay. All right. Now, this is all goofed up here again. We might get, for example, don't worry about this part. Let me just do this real quick here. We might get a non-metal that reacts with a non-metal. Okay, this isn't as common. So we'd say AX plus Y, and what would happen is the X and the Y would switch positions. So the non-metal would switch with the non-metal. And we get AY and X instead. Okay. Now, I'll show you how to tell the difference, okay, with these ones. How do you know you're switching the non-metals, or how you know you're switching the metals? And that really comes from basically what you're given in the first part, okay, the reactants, basically. So don't worry about that part there, guys. We're going to do it at the bottom here. Cl2 and NABr. Okay, here we go. So Cl2 and NABr. Okay. Now look. Before, right, on the last couple of examples, I said, hey, the metal will switch with the metal, yes? Okay. This one is a non-metal here, yes, by itself. So the non-metal can't switch with the metal because then we'd have 2 negatives. The non-metal has to switch with the non-metal. Okay? So either it's the metal and the metal that switch, or the non-metal, chlorine's on the right-hand side, guys, of the periodic table. It's on the right of the staircase. That's going to switch with another thing that's on the right-hand side of the staircase. So non-metal, non-metal switch. And what we'd end up with is Br is going to come out by itself. But remember, bromine comes in twos. I have no bright twos. And the chlorine's going to come and take the place here. So these two are going to switch positions. And I'm going to get Na and Cl, 1 plus, 1 minus. And that'll be aqueous again. By the way, bromine actually it turns out to be a liquid, doesn't it? It's in blue over there in writing. Okay? And now we need to balance based on this. All right? And I'll give you another example here, obviously. Let's see. 2 Cl's here, 2 Cl's here. 2 NAs, 2 NAs, 2 BRs, 2 BRs. Looks good. Okay? So the nonmetals may need to switch positions. That's not as common. Okay? Most of the time we talk about metals and metals switching places, not nonmetals and nonmetals, but it could happen. All right, let's take another look at an example here. Let's take a look at this one. Once again, we probably need to write down a few things here, guys. Balanced chemical equation for the reaction between liquid bromine is added to a solution of aqueous iron 3 iodide. So go ahead and write down that. And then, so reaction between liquid bromine comes in twos. I have no bright or clever friends, people stupid, right? And iron 3 plus, iodide's a 1 minus. Swap and drop. An aqueous solution, aqueous iron 3 iodide. 3 plus, 1 minus, swap and drop. Okay? In this case, once again, we see here, hey, we have a nonmetal. Bromine is a nonmetal. It's on the right-hand side of the staircase. It will therefore switch with the nonmetal, which of course is I in this case. Those need to switch positions. So I is going to come out by itself. Okay? This one's going to come over to here by itself. I have no bright or clever friends. People stupid, right? I too. By the way, if you look over there, iodine is in gray lettering, so that's actually a solid here, guys. Okay? I2, solid. And the Fe and the Br go together. Hey. You're off. So the Fe and the Br go together, yes? So, iron, once again, most common charge of iron, 3 plus. Br would be a 1 minus. So 3 plus, 1 minus, swap and drop. Okay? And because it's an ionic compound, we'll call it aqueous. Okay? This one's going to be a little trickier to balance because we have some issues here. 2 bromines here, 3 bromines here. How do I fix that? 2 and 3. How am I going to fix that? Yep. Yep. Put 3 here, right? 6. And put 2 here. 6 bromines. Lowest common multiple of 2 and 3. 2 times 3 is 6. Okay? Usually that works. 2 times 3 is 6. So we want to make 6 and 6 on both sides. Okay? I now have how many Fe's here? 1. I have 2 Fe's here. So I'm going to put a 2 here. And then I have 6 I's. 6 I's. And these come in 2's. So I need to put a 3 there. Okay? That's kind of a tricky balancing one for sure. Okay? So in that case, the nonmetals will switch places. Okay, not very common. Might give you some practice on that, obviously, but not as common as the metals switch places. Good? Okay. Next. Ooh, let's see here. Well, let's talk about this one. If you actually do this, and you know what, you could just probably write out, I'm not going to do the demo today here, but sodium metal is placed into water. I kind of like to leave this one actually for grade 11, but we'll see. It's kind of cool. So if you place sodium metal is placed into water. So let's just write that out. Sodium metal is put into, reacts with water. Now, let me ask you this. Sodium is what? Sodium is a metal, right? In water, do we have a metal? Do you see a metal there? No. Okay. Now, so this is obviously very tricky. Okay. This one is probably like, you know, this is, you have to know a little bit more about water than just what you see here. There's no metal with water, right? You know, when we talk about metals, we talk about like sodium or potassium or calcium or whatever, something left of the staircase. But I don't see any of that in here, okay? What you do have to understand is actually what takes place with this is what actually takes place is that water is actually made up of two parts, can be made up of two parts, okay? Now, this one is tricky, and this would be kind of like a good bonus question. Water actually, when you drink water, okay, you are drinking H2O, obviously, molecular compound, it's neutral, okay? Water has the ability to split into two ions by itself. So water actually is made up also, little tiny parts are made up of H+, which we know is what? If I said H+ to you, you should tell me what. That is a what? Yep. Yes, that is the metal part. What is H+? We studied this already, guys. H+ is actually a property of what? H+ is responsible for what? Should know. If we put H+ at the beginning of a formula, that makes it a what? An acid. Okay? An acid. So that right there, what I've put there, that is an acid. But, like I said, this will break up into this and that. Okay? What's OH minus? You know this too, yep. Base. Okay? So when you drink water, you're mostly drinking H2O, but in every drink of water, you are going to be drinking some H+. Luckily for you, though, you're drinking an equal amount of OH minus, okay? In the same concentration, the same amount. So you have a little bit of acid, but a little bit of base in there as well, and they neutralize each other out. That's called ionization of water, okay? So now, if I said, hey, what's sodium going to replace in this formula, H+ or OH minus? Sodium's going to replace what? H+ or OH minus? It's going to replace H+, isn't it? Okay? And those two will switch positions, and you will get H that comes out by itself. H is a molecular element, and it's a gas. So you'll get hydrogen gas that comes out. The sodium will combine itself with the hydroxide. 1 plus, 1 minus, like so. Yep. Yep. Okay. And you would get a very basic solution. Okay. That one's tricky, but that's actually what takes place there. It's also very exothermic. So it becomes very hot. You would see a lot of smoke. We probably should go and do this someday, don't you think? Have you done this before, anyone? Oh. You want to see some magic? How about tomorrow when we're doing a review of equations? That'll be the best day to do it. Okay? You remind me. After we get done everything, we'll do some review. Okay? We'll go to the lab. um, I will do some magic for you. Okay. So they will take places. You'll actually see the hydrogen gas. You'll see some smoke coming off of there and stuff, some gas. And you will see the solution turn to sodium hydroxide, and you'll see what that looks like too. Okay. That one's, like I said, a little tricky, but that's a little challenging. We're going to look at double replacement. Okay, next. Okay, double replacement. So copy that down. In a double replacement reaction, the cations of the two different ionic compounds switch places. Okay. And don't worry about this bottom part here. In fact, I'm going to block you there. Okay. I'll let you copy. Okay. Double replacement reaction. Double replacement reaction, cations switch places. They're the first parts of the ionic compound. They'll switch places. They're the metal ions that switch places. Okay. If you want to come up with a general kind of thing here, let's call it AB, positive, negative. Okay. CD, positive, negative. And the two metal parts will switch. Okay. So A and C are going to switch places. So we're going to get CB, CB, okay, and AD. And you might say, well, can I write AD first and then CB? Absolutely. Doesn't matter which order you put the products in, as long as you get the right ones and you balance it properly. Okay. Now, we'll talk about that in a bit here. With these, you will need your solubility chart. Okay, because we need to know which ones are going to be soluble, AQ, which ones are going to be solids, precipitates. Okay, an example here, barium, okay, and sodium sulfate. So, no, I forgot it already. What is it again? Barium hydroxide, sodium sulfate. Okay, barium hydroxide and sodium sulfate. Okay. Now, I usually run out of room because I like to write it nice and big here. So, and once again, we'll talk about the products here. Okay. Barium hydroxide, sodium sulfate. This could be a word equation as well, of course. Okay, so we could say barium hydroxide mixes with a solution of sodium sulfate. What are the products? Balance it, etc., etc. Okay, so you'll notice here, first things first, ionic compound, ionic compound. Two ionic compounds. The cations, the metal parts, switch places. So barium is the metal, switches with the metal. Those two switch places. Okay? You're going to get new formulas because remember, we're combining them with different ions, right? Okay? So look. Sodium is going to go with hydroxide now. So the sodium, Na, right, goes with, in this place here. So NaOH. Now look, sodium's a 1 plus, hydroxide's a 1 minus. Okay? And barium is going to come over and take the place of sodium here. So barium is going to go with sulfate, SO4. Okay? Barium is a 2 plus, sulfate is a 2 minus. Swap, drop, and reduce. Okay? Now, this is important. Okay? Very important. We need to know, in a double replacement reaction, we usually get a precipitate, a solid that's formed. So you're going to grab your periodic tables, guys, now. And you will find, remember, we look this up. How do you look it up? You look at the negative part first, right? So find OH minus across the top here. Follow with me, guys. There's OH minus, yes? Where's Na 1 plus? Is it group 1 Is Na1 plus a group 1? Yep. Na right there, group 1. That's very soluble, right? That's the very soluble row. So I'm going to put here AQ, very soluble. Okay. You then are going to find the other one. So let's look, BaSO4. Find SO4 across the top. Where is it here? Right there, yeah? Okay. Where's Ba? It's listed in the bottom there, isn't it? And the bottom ones, remember, are the slightly soluble, otherwise known as precipitates. Solid bottom. SO4, not here, it's down here, Ba2 plus. Okay, solid. Now, that's important. That's the states of those two compounds. We now need to balance it still. Okay, so here we go. Ba, Ba. You could say that one has a bad attitude. No. Two OHs, 1. So let me put a 2 in front of there to fix that. Okay. 2 NAs, so that's good. SO4, 1 SO4, 1 SO4. That's good. Okay. So there's your balanced chemical equation for that one. Yes? Okay. Questions? Anyone? No replacement. Okay. Let's look at another one. Once again, we talked about the solubility table. You're going to have to use that. And here we go. Let's take a look at this. Holy. Let's get rid of that for a second. All right, there we go. Now, once again, take a look at this example here. You will have to write this down. Okay. So when aqueous lead 2 nitrate and sodium iodide are mixed, you get a bright yellow precipitate formed. Write the chemical equation for this. So go ahead and write that example down, guys. Let's see. So aqueous lead 2 nitrate, lead 2 nitrate, okay, 2 plus, 1 minus, swap and drop, brackets, aqueous, and sodium, 1 plus, iodide, 1 minus, aqueous, gives me, once again, the metal parts, the 2 positive ions will switch places. So we are going to switch Na and Paba. Okay? Peanut butter and Na will switch. Pb and Na, the metal ions. So let's write this one. It doesn't matter which one you write first, but Na is going to come here, NaNO3. NaNO3. You need to use charges. 1 plus, 1 minus, swap and drop, we're good. Okay? Pb and I are going to go together. So Pb is going to come over here, mix it with I. Now it's Pb2, and I is a 1 minus. So we're going to get that. Okay? So lead 2 iodide. Okay? You're going to have to look up the states. Look up nitrate across the top. Na, very soluble. Pb and I. So find I minus across the top. Find Pb 2 plus. Should be in the bottom. Somewhere there. That will make it the solid. Okay? So obviously this yellow precipitate they talk about would be the lead 2 iodide. Okay? Yellow precipitate, bright yellow. Okay? We do need to balance it. So let's not forget about that. Pb, 2 NO3s, 2 NO3s. 2 NAs, 2 2 NAs. 2 I's, 2 I's there should be good. Okay? And that would be the balancing for that. Okay? Good? Yes? Okay. Let's do this one here. This one here says write a balanced chemical equation for the reaction of copper 2 bromide and aluminum chloride. Okay. It says here all products are aqueous, so technically there's not really a reaction that takes place. However, we can still write out a balanced chemical equation, but really this probably would not take place. Okay. So copper 2 bromide, aluminum chloride. Okay. So copper 2 bromide, aluminum chloride. Aluminum's a 3+, chloride's a 1-, swap and drop. Okay. Metals switch places, or the positive ions or the cations. So we're going to get aluminum that goes with bromine here, bromide. Aluminum and bromide. 3+, 1-, swap and drop. Okay. And copper is going to go with chloride. Copper 2 chloride. And apparently they say that these are all aqueous. Oops, aqueous. And that this reaction probably wouldn't take place. In fact, what you would probably see in this case is not a lot of difference from what you start with. Okay, we can talk about that down the road here. Okay, so balancing though, copper, so that's good. Br2, Br3, that's not good. Okay. 2 and 3, when you run into that problem, we got to switch the numbers around. We got to make the lowest common multiple. So I need to make 6 on both sides. So I'm going to put a 3 here. So that's 6 BRs. And 2 times 3 is 6 BRs. While I've done that, though, I need to go back and switch the other ones. So 3 coppers, and 2 aluminums, and 2 aluminums. Okay. 6 chlorines, we're good. Okay. All right. Questions, anyone? Questions? Okay, metal's got to switch places. And last one here, what do we got? Let's just do this one together real quick here because I want to give you a little extra time here. We're running out of time. Silver nitrate, 1+, 1-. Yes? Silver's a 1+. Nitrate's a 1-. And if you don't know this stuff, that's okay. That's what you got a periodic table for. It's going to take you longer. That's okay. Silver nitrate. And potassium phosphate. Potassium is a 1+. Phosphate is a 3-. So swap and drop. 1+, 3-, swap and drop. Okay? It says that these are both solutions. So let's put AQ here. AQ, and what are we going to get as products? We switch the metal parts. These two will switch places. So we're going to get K and K. I know it's K3 there, but that's specific. K goes with NO3. K and NO3 go together. K, NO3. Now, before you move on, K is a 1+. Look that up on the periodic table. NO3 is a 1-. So we're good. 1+, 1-. Perfect. And I said AG is going to come over to here, and it's going to go with PO4. So AG, PO4. Okay? Now, listen. AG is a 1+. PO4 is a 3-. So the 3 needs to come over and down. Okay? We need to look up solubility for these ones. NO3 across the top. K is group 1, aqueous. PO4 across the top. Actually, I don't remember this one. PO4 across the top. And AG1+ would be in the bottom the most. So that is your solid here. Okay? Balancing. 1 silver, 3 silvers. So 3 AGs, 3 AGs. 3 NO3s, 3 NO3s. 3 Ks, 3 Ks. A PO4 and a PO4. And it looks like that is good. Okay? All right. You guys have some practice in Google Classroom now. It's there now.